Why stats or statistics is important for machine learning project, and what is the connection between maths, stats, numbers, and machine learning project? If you're someone who are new to machine learning or someone who is a student of machine learning, this video can help you a lot, because in this video I'm going to talk about the connection, the relationship between the stats, math, numbers, and machine learning model, and how to analyze some data, some numerical data. What are the different tools, different methods which are available in the stats, and how you can best analyze the data with these all tools. Okay, so this video will be helpful for you if you are someone who really want to master or upgrade your skill into stats, and in Python, in machine learning, you want to understand the entire connection. This will definitely help you. Okay, so I'm going to cover very basic idea about the stats in maths using Python, and I will show some data, and we will understand how to analyze the data with respect to stats and Python. Okay, so let's get started, and then let's understand the importance of stats in machine learning project. Let's get started. Before we start the stats in this video, I have a disclaimer. By the way, stats is a huge topic. I'm not going to cover the entire topic. So I'm going to cover the topic which is important with respect to machine learning project. Okay. And in this video, I'm going to talk about basic concept, very basic concept about central tendency, which describe the about the data. Okay, so before we start the concepts, first of all, let me discuss that. First of all, why it is important as a machine learning developer or somebody who is a student of machine learning, you should know stats or math or numbers. Okay, because see, in the machine learning project, you know that you have to deal with multiple models. There are multiple already inbuilt models in machine learning, like regression, like logistic, like classification, like there are so many models. Okay, these all models needs data, right? And in order to pass the data to this model, you have to understand the data in very detail. I mean, you have to understand the relationship between data, how the data are distributed, how the data are scattered, how the data are completely related to each other, and which data are missing, which data I need to discard, which data I need to accept. A lot of pre-processing happens. And in my understanding, in my experience, your 80% effort, if you're working in a machine learning project, your 80% effort goes into this part, which is called EDA, okay, where you have to understand mainly data. Okay, and in machine learning project, actually the data are two kinds of data. You will find there are two kinds of data. One is the numerical data, one is called categorical data. For example, let me show that. For example, here I'm loading couple of data. I will explain that. Okay, so this column is called total. It's a total fare. Okay, so you can see that it is coming into the numbers like $12, $9, $14. Okay, so these all are numerical kind of data. And there's another data which is kind of like CT, the CT name. It can be a categorical data. Okay, so mostly we deal with two kinds of data in data science project. So for the numerical data, if you want to understand very well about the numerical data, their relationship, so for that, stats come very handy, and stats gives you as a tool, as a framework, as a method, as a tool to analyze the data pretty well. Okay, so that is why as a in the machine learning project, it is very important, it is essential to learn stats, and these are the basic concepts. Okay, so in this video I'm going to talk about a central tendency, which is the very important and very simple part, but very at the same time very important part of the stats. Okay, so let's suppose if I give you numbers, for example, totals. I have, suppose it can be 1,000 numbers, right? Generally in the data set we have 1,000 rows, multiple rows, to 2,000 rows, right? So we have a, let's suppose total, we have multiple totals, right? So suppose you have a huge data set, right? And in I want to understand how to provide a summary to this whole long data set. in simple word, how I can describe my uh, range of data set into a single word. Okay, so that is why your central tendency come into picture. For example, let's understand this way. Suppose in a classroom there are 100 students, right? And every student has scored some marks. Let's suppose in mathematics subjects, so there was a maths exam and 100 student has scored some numbers, some marks in the mathematics subject, right? So you will get 100 data points, right? But I want to summarize this whole 100 data points into a single number. How to do that? So that is why central tendency, this concept which I'm going to talk about, comes into picture. Okay, so in this concept, what you have to learn, which is very basic, and I know that majority of you might have already seen this concept maybe in your class 11th, class 10th standard. For example, it has a mean, median, mode, standard deviation, variance, range, IQR, Z-score. This is very important. Skewness. These all are the basic concept which part of descriptive stats. Okay, so descriptive stats talk about the summary. It gives you a description about your data, so that you can make some decision based on those description. Okay, so let's start now. I hope you this all concept you already know. What is mean, what is median, what is mode. Okay, if you don't know, let's suppose I'm assuming that you don't know. If you already know this whole concept, you can skip a video. Otherwise, you can stay here. Okay, for example, mean. Okay, mean is average. Okay, so how to it's a complete mathematics. I hope you know that. So how to calculate mean. Okay, for example, here I'm using ChatGPT for that. Explain, just I'm asking explain mean with some example. Okay, it's very simple. It's not, means is very simple. I'm just for the explanation purpose I'm using that. Okay, so how to calculate mean? Suppose you have a data set point. Okay, suppose 100 student marks. Okay, so I can find that out of 100 marks, what is the average mark? It can be, I mean, what is the average mark people student has scored? It's a 60%, 40%, whatever. Okay, so how to calculate average? Suppose you have this data set 70, 80, 90, 85, 95. Okay, so how to find the average? Very simple. In mathematics, just do the summation of all the numbers. Okay, and divide the numbers by number of value, I mean the number of observation or number of data point, which is the 5 here, right? I have total 5 points, so I'm going to divide by 5. So the value will come, it becomes like a mean. So it is called the mean. Okay, for example, like this, right? So means is, finding the means is very simple. Next is the median. Okay, so median, again, median, explain the median. So median is called the midpoint. Okay, let me explain that. So mean is the average point. Okay, median is called the middle point. Okay, so in order to find the median, what you need to do, you need to first uh, you need to sort, or you need to sort your data point either in ascending order or descending order. Okay, in my experience in data science project, it is always good practice to sort the data into ascending order. Why it is important, though you can do in descending order also, but in the best practice it is ascending order. Why it is important, I will discuss later. Okay, so this way, if you arrange the data in ascending order, okay, for example, like this, suppose I have 5 data point, right? I'm going to sort it. So the first is 5, 7 in increasing order. So it will come 5, 7, 9, 12, 15, right? Out of this data set, what is the middle point? You have to find the middle number, right? So the middle point is called the median. So for here, the middle point is what? 9, right? So it had total 5 points. So out of 5, this number is a middle point, right? So in case of odd number, if your data points are odd, you will find one median. Okay, in case of even number, suppose this number, you have even numbers of data point, for example 8, 12, 15, 17, 21, 25. So it has how many? It has 6. So it has total 6 observation or 6 data points. It is an even number. Okay, in that case, what we'll do, we will, in that case, there will be two medians, there will be two middle points. In this case, it is a 15 and 17, right? So to find the median, what I need to do, just add these two numbers, which are the middle point of this data set, because it has an even number, and divide by 2, because it has two data point. Okay, you will find the 16. Okay, so here 16, one point to note, that in case of odd observation, your median is the part of data point. I repeat, if you are dealing with odd number of data points, then the median will be the part of the data point. For example, 9, which is the median, it is the part of my data set, right? But in case of even numbers of observation, if you have an even number of set of data points, your median, it can be the part of data set, or it cannot be the part of data set. For example, in this data set, my median is coming 16, right? So here there is no 16 in the data set. There's no 16. So it is not the part of the data points. It is okay. But here this 16 is giving me a, it is giving me a story. It is talking about that for this data set, what is the middle point? 16 is the middle point. It does not matter whether it's a part of data point or not, but it is giving a whole picture, right? For this complete data set, what is the middle point? Is a 16. So this way I can find the middle point. Okay, this is what median. Next is the mode. What is the mode here? Okay, so mode is, let me explain. Let's just talk what is mode. What is mode? Give me some example. I'm just using AI chat GPT just to explain. Okay, example. So let's understand mode. Okay, so modes talk about the frequency. Okay, I mean, how many times a particular data points are repeating in that observation. Okay, that is called mode. Okay, so mode is identify the number that appears most frequently in the data set. Okay, so there could be chance that data sets are repeating in that data set, right? So which is the most repeated numbers? Okay, it is called, it can be possible, it can be one mode, two mode, more than two mode, this is also possible. Or maybe there could be no mode. If there is no repetition happening in the data point, there could be no mode. Okay, for example, here you can say 3, this is the number, suppose this is my data set. In this data set, arranged in this order, okay, you can see that the 7 is repeating the most 4 times. Okay, 2 is repeating 1 time, 3 repeating 2 times, 5 repeating 1 time, 7 4 times. So 7 is the most frequent number in the data set, right? So the mode for this whole data set is 7, right? Similarly, it can be two modes. For example, here in this data set, 17 is repeating 3 times, 1 2 3, and 12 is repeating 3 times, right? 12 1 2 3. So these two numbers, 12 and 70, are repeating the most frequent time, which is 3 times. So that is why mode is 12 and 17. Okay, so mode is always a part of data set, because that is repeating most time. Okay, and one thing, generally the mode are used in case of categorical data, mostly. Okay, let's suppose you have a multiple color. Let's suppose in the data set you have 3 colors. One is a red color, you have blue color, you have a green color. Okay, I just want to understand which color is repeating the most time. So this way you can find the mode. Okay, so mostly mode are used in case of categorical data. Okay, so this mean and mode, and this mean median mode talks about the central tendency. It gives you the picture, the entire data set, what is the middle part, what is the average part, what is the middle part of the data set. It talks about the middle part. Okay, now the next concept talks about the dispersion. So dispersion talks about the spread. If you have a data point, right, and how these data points are scattered, what are the spread in the data point. Okay, So for that, we understand these are some tools like standard deviation is very important, variance, range, IQR, Z score. These are the important point which talks about the spread of data set. I hope this all concept is very basic. I hope you already know this all concept, but still I'm repeating. Okay, if you don't know, then this video can be useful for you. Okay, so first of all, let's understand the standard deviation. Okay, so for that, what I'm going to explain here. Okay, let me explain the basic concept. Let's suppose this is one line, right? And here in this line, I have multiple data set. Okay, let's suppose I'm plotting two lines. Okay, suppose this is the median. Okay, so in this line, I can have multiple data points, right? So let's suppose I have one data point here. I have data point one here. I have one here. I have one here. So here now I'm plotting multiple data points, right? This way. I have one here, I have one here, I have one here, I have one here, one here, one here, one here. Let's assume that way, okay? This is one scenario. In this scenario, let's suppose I have one data point here, I have data point one here, I have data point one here, I have one here, I have one here, right? Okay. So now from these two, so this talks about how the data points are distributed in the given data set. Okay, so you can see that in this case, right, what is the observation? So in this case, you can see that data points are very close or very concentrated, right? They all the points are very close to each other, right? In this part, in the second part, you can see that data points are spread. There are a lot of spread. I mean, data set are the density is less here. Okay, these data points, all the data points are scattered in a long distance. They are not concentrated. In this case, all data points are concentrated around my mean. Suppose this is my median. So all data points are very concentrated around the median or mode. Okay, in this case, I can say that my all data points are scattered or they are very spread. Okay, so this way, so how to find? So method, okay, from the picture, from the diagram, I can see that. Okay, but if you really want to use this whole concept in machine learning model, I need some tool, and for that we use standard deviation. This is also called lambda, like this. Okay, it's a mathematical symbol. Okay, so this talks about the spread, I mean density of your data points in the given sample. This is very important. Okay, and how it is important with respect to machine learning model, it is important because your model is going to depend upon this data set, right? So if you suppose you have trained your model with this data set, right, where your data set has a lot of density or the spread is less, right? So maybe your model will not have a much variation because you have already trained your model with this data set where the variation is less. You're trying to understand, right? In this case, there's no much variation. The standard deviation is less in this case. But in this case, there are more variation. In that case, your model is going to, you have trained your model in such a way that it can take some abnormal or it has more wider, it is more wide, or it can accept more variance, okay, or variability of the data. So stats talks about, there are two things. In the stats, we talk about two important things, okay? Let me explain that. One is called, uh, okay, so stats, it talks about two important things. Okay, one is called randomness. Okay, so actually stats solve these two problems: randomness, how your data is random, and variability. Okay, what is the variation in the data? Variation is very important. Let's understand how your data are. Suppose you are taking some sample, right? So it can be biased in the model. It can be biased, right? If your data is so is so dense, or it is not, your data set has no much variance, maybe your model will not give a good prediction. I'm just giving just idea, right? So that is why we have to understand that the data which I'm giving in the part of training, that data set has a lot of variance or not. Okay, so that talks about this concept talks about uh, okay, so this concept is handled by standard deviation. Okay, now mathematically how to calculate that? So you uh, just explain standard deviation with example. Okay, so how to calculate is very simple. So I'm asking ChatGPT just for explanation purpose. Okay, so it's a measure of a spread out. I mean, how the numbers are spread in the data set. Okay, it tells you whether data points are close to mean. This the same concept, right? I talk about, right? Whether your data points are very close to mean, very dense to means, or it is scattered, or it is widely spread out. Okay, if it is widely spread out, then your deviation will be high, your standard deviation will be high. Or if it very less, or it's very dense to about mean, then your standard deviation will be low. Okay, so how to calculate it? All the data set standard deviation, this is a formula, it's a mathematical formula. Okay, so actually what we do here, we find the distance, okay, from the mu. So suppose we have multiple data point x1, x2, x3. Okay, so for each data point we are finding the distance from the mean. It is called mu. Okay, mu is called average or mean. Okay, so what is the distance from the mean for each data point, and we squaring it. So it is basically in the coordinate geometry, it's a actually it's a distance. Okay, so if we finding the distance of each data point from the mu, and we are dividing by number, we are finding the average and doing a square root. Okay, so this is the mathematical formula to find the standard deviation. Okay, for example, this data set, suppose I have a 10, 20, 30, 40, 50, right? For this data point, you can see that, just look the number. Okay, just look the number. One is 10, then 20, then 30. It's a 10-10 gap, right? So in this case, I think the mean will be high, standard deviation will be high, because it's a widely spread. Okay, so how to find that? Okay, so first you find the mean, find the average, which is 30. Okay, and then each data point you apply this formula, find the distance. So each what is the distance of each data point from the mean? How to find that? 10 minus 30, okay, minus 20, and square it. Okay, and then 20 minus 30 minus 10, 30 minus 30 0, 40 minus 30 10, 50 minus 50 50 minus 30 20. Okay, and it's every distance, because it's a distance, right? I'm going to square it. So this is square, a 10 square, 0 square, 10 square, 20 square. Okay, and finally you will get 400, and 400 divided by 5, because I have total 5 observation. I have total 5 numbers of data point. So 200. You can see that. So and square root of 200, it will comes around 14. So spread is, I mean, you can see that these data sets are having the good spread. Uh, they are spread. Okay. For example, let's suppose, now let's compare with two data sets. Let's suppose this is one data set. It has 10, 12, 14, 16, 18, 5, 25. You can see that in this data set, what is the gap between 2 points? 10, it's a 2 gap, right? 2 gap. In this data set, it's 5, then 25, 20 gap. 25 feet 50, again 20 gap, 20 gap, 20, 75, 100, huge gap, right? So you can see that these data points are widely spread out, right? And these data points are not much spread out. It is very close to each other, or it is very close to mean. Okay, so in the first case, the mean is less. It is the mean, right? So in the first case, to find the standard deviation, in the first case, uh, first data set has small st. Okay, so in this case, this data set will have lower st, I mean standard deviation, because all data set are very close to each other. They are very close to mean. Okay, so in this case, it is coming 14, it is coming 51. Okay, so this way you can calculate. Okay, so this talks about, okay, so this standard deviation only talks about the spread, how the data are spread, okay, among each other. Okay, I mean how much variance you have. So similarly, there's a concept called variance. Okay, so variance and standard deviation is almost same. Okay, so let me explain that what is a variance. In case of in case of standard deviation, what we'll do, we find the square root. Okay, but in case of variance, we don't find a square root. Variance is very simple. Explain with example. So how to find the variance? First do the square. We don't do a square root. Okay, so you can see that in case of standard deviation, we do the square, a square and square root. We find the root. Okay, in case of variance, we don't do square root. We just do the square. I mean, just find the distance of each data point from the average and divide by number. Okay, so this is called the variance. Okay, so both the standard deviation and variance talk about the spread. Okay, yeah, but there are some different use of it. I'm not going to talk about that, but mainly it talks about the spread of the numbers. Okay, next is the range. Okay, so range talks about, it's very simple. Range talks about what is the minimum point in my data point and what is the maximum. So it's a distance between minimum and maximum. Okay, you find the minimum, you find the maximum. So it gives a complete range. My data set is from this point to this point. Okay, it never talks about I mean, what is the mean, what is the medium, what is the spread. It talks about the range, right? Okay, next point, which is very important. It is called quartile. Okay, it is called IQR, interquartile range. Okay, so let me discuss that. Okay, what is quartile? For that, let me explain this graph. It is very basic one, which I'm talking about is very basic one. Okay, it's a 9th or 10th standard concepts. Okay, so okay, IQR, quartile. Okay, so for example, here, let's suppose this is my numbers. Okay, suppose I have 10, I have 20, I have 25. Okay, I have suppose is that 50, I have 55. I'm just taking some random number. I have 60. I'm taking in the sorted order. Okay, and I have 70. Okay, I have already sorted it, right? So from this from this data point, what is the median? Okay, you can find that it has three here, three numbers here, three numbers here, and one in the middle. This is 50, right? Which is already sorted. Okay, so in this data set, 50 is my median. It is a median point, right? And to the left, so so this median, one thing, this median divide the whole data set into two parts. This is very important. Okay, this whole median dividing this whole data set in two parts. One is the left of the median, one is the right of the median. Okay, this is one part, two parts, right? Now out of it, okay, suppose I'm talking about suppose this is the right side, right? This is the right side, and this is the left side of the median, right? So this median, okay, so this median is dividing the the whole data point into two point, okay, into two different parts. Okay, so this part, if you talk about the left part, okay, now from this left part, which is 10, 20, 25, you will find another middle point, right? And from the right side, which is 55, 60, 70, you will find another midpoint, right? So here, this midpoint, which is the median, it is called Q2, second quartile. Okay, and this left side, it is called Q1, first quartile, and the right side, it is called Q3, the third quartile. Okay, so here, this way, we divide the whole data points into Q1, Q2, Q3. So median is always Q2 because it's a middle part of the data set. Okay, like this. So this is called Q1, this is called Q2. Okay, and this is called, sorry, it is called Q3. Okay, and the distance between Q1 and Q3, this distance, okay, this from here to here, the gap, this gap is called IQR. This gap is called IQR. What is called? IQR, interquartile range. Okay, this is called IQR. Why it is important? Okay, first of all, let me explain what is quartile. Okay, if I'm saying that, suppose I'm making this statement, suppose this is 20. Okay, suppose I'm making my statement that my Q1 is 20. Okay, and my Q2 is 50 and my Q3 is 60. Suppose I'm making this statement, which is true here, right? It means that if I'm making a statement that my Q1 is 20, it means that your 25% of data is either 20 or less than 20. Okay, and if I'm saying that my Q2 is 50, it means that my 50% of data is either 50 or less than 50. If I'm making a statement that my Q3 is 60, it means that my 75% of data is either 60 or less than 60. Okay, so Q1, this part, okay, so how it works, so this portion is 25% of whole data, this is 25%. Okay, and and uh, and from here to here, let me remove this. Okay, so this is a concept. So this data point, okay, this is the 25%, and here from beginning to here till Q2, it is the 50% of data point. Okay, this is the 50%, and from here to Q3, okay, it is from here to here, from Q3, it is a 75% of data point. Okay, so uh, your Q1 divide the whole data point into 2 points. First is the 25% and remaining 75%. Q2 divide the data point in two parts. 50 this is the 50%, 50%, and Q3 divides the whole data set into 2 parts, 75% and 25%. Okay, so you can see that. So this range is very important because till here, okay, because from beginning to till here, till Q3, you have 75% of data. Okay, until here you have a 25% of data, right? So if you subtract 75 minus 25, how much it comes? 50. It means that between this range from Q1 to Q3, this range, you have 50% of data here. So this range IQR, all your data, you have a 50% data sets are present within this range IQR. Okay, so that is why IQR is very important. So IQR, it's an interquartile range, and your 50% of data, 50% of population is within the IQR. Okay, so this way it is giving the importance. So your all the data around 50% data is within that range. I hope you understand that. Okay, so this everything is giving the whole picture, how the data is looking like. I mean, what is the central part, how the spread is there, what is the range, okay, and how the data is scattered within a given range like IQR. This is important, right? And next topic, I want to talk about JEDA score. I have seen that personally, a lot of people misunderstand about z score. What is z score? Okay, so let me explain that. What is z score? Again, z score is very, very important in terms of machine learning, in terms of uh, probability, in terms of, because we heavily use z score concept. Okay, so I'm not going to discuss in very detail uh, in this video about z score. Maybe I will create another video for that. But z score is very, very important. So let's understand. Okay, what is z score? Okay, it it has very wide use in stats and machine learning. Okay, so what is z score? Okay, so let's suppose this is the spread. This is my data point here, right? And let's suppose this is my mean. Okay, here is my mean. This is my mu, my average. Okay, let's assume it's zero. It's this point is zero. This is my mean. Okay, and this data point I can find the standard deviation, right? So I for that I can find the mu, right? I know what is my mu, what is my average of my data point. I can find that. And suppose I have multiple data point. I have x1 here, I have x2 here, I have x3, x4, x5. I have multiple data point, like here, like here, like here, like here. I have multiple data point, right? So I can find the standard deviation. So these 2 points is prerequisite. If you really want to find the z score, it's a prerequisite that you should know the mu. I mean, what is your average, and what is the standard deviation. Okay, these are the prerequisite in order to find the z score. Let me remove this. Okay, so what is z score? So the z score talks about that any points, okay, in the observation. I'm assuming that you know your mu, you know your average, and you know your standard deviation. I'm assuming that. Okay, so how to find the z score? So z score talks about that any point in the data set, okay, how times, how far, I mean, this data point is how far from the mean. Okay, how many times, how many standard deviation times it is far away from mean. Let's suppose I'm making a statement for in order to explain that. Okay, this is my statement. Okay, I'm making a statement that, let's suppose this is point x. Okay, I'm saying that the point x is 2 standard deviation away. Okay, I'm making a statement from mean, from mu. Okay, this is my statement. I'm writing this statement. So this point x, it is 2 standard deviation. So this gap, okay, this gap from mu is how much? Mu plus 2 standard deviation. Okay, so this is called z. Okay, so z talks about how many times it is, how many standard deviation times it is away from mu. For example, it is 2 from here, this point is at this point from 2 times standard deviation. So for this point the z will be 2. Z will be 2, right? I mean, if I'm making the statement that for this point z is equal to 2, it means it is 2 times of standard deviation it is away from the mean. Okay, so mathematically how to find it? So there's a formula for that in order to find your z. Okay, so there's a formula. So formula is this: z is equal to, okay, we find the z for any point. Okay, so x is my point, x is my observation, minus mu. Mu is the average of the whole sample of whole population, and lambda is the standard deviation, right? So for that we find the x z of x, I mean z score. Okay, so this is the mathematical formula. But logically what it talks about, if you find let's suppose if I put this way, if you I can, the same formula I can write like this. like x is equal to mu plus lambda into z, right? I'm just rearranging the same equation. Okay, so this, it gives a distance, right? So this x point is away from mu, right? X is equal to mu. I mean, this point is away from mu. How many times of uh, z can be some number, okay? 1, 2, 3 number, right? So it says that x is equal to z time of standard deviation. It is away from mean, right? So this is the it is this way we can find z. Okay, so z talks about so z is a number, and we find z a score for every data points in the given sample, given population, and it talks about the spread. I mean, how far any point is away from the mean, from the average. And generally we talks about in terms of standard deviation. How many times from standard deviation it is far away from the mean. Okay, this way we find the z score. Okay, so here, and why it is important, it has a wide use in machine learning. I'm not going to cover that because it's a huge topic. Okay, maybe in another video I will give a whole picture about z score, what is z score, what is important of z score, and we use in multiple places in machine learning algorithm, machine learning project of z score. I'm not going to cover that, but mathematically this is the concept of z score. It talks about any point, and we find the z score for every data point in given observation. It talks about for any data point how many standard deviation it is away from the mean. It's a spread. Okay, so these are the basic concepts. These are the very basic concept about stats. Okay, yeah, so as of now, in this video I cover only the basic part, what is the basic meaning of this all thing. Okay, the next part I will talk about this whole concept which I talk about is very basic concept, how to leverage, how to do some analysis with some data using Python. Okay, I'm not going to cover in this video because the video can be a bit longer. Maybe in another video I will talk about that like whatever I discuss in this video, all the basic concepts, how to leverage with respect to Python and with some data point. Okay, so this is all in this video. My intention was to give a very basic idea. I know that majority of you maybe might be already knowing these concepts. Okay, but these are very basic concepts, and why it is important, because your observation, your data processing, especially for numerical data point, it will totally depends upon these concepts. And a lot of people make a lot of mistake. For example, IQR, Z score, this concept. Okay, so this is all in this video. It was a basic one. In next video, I will give the complete example or analysis of data with Python. Okay, I will create another video on maybe the second part of this. Okay, so this is all in this video. I hope you got a lot of value, you got a lot of learning from this video, and I will come back in the next video, the second part of it, where I will explain whole observation with Python. This is all in this video. Goodbye, take care. I will come back.